Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is our next problem. Problem having been chosen from the same book, Modern Physics, by Stephen T. Thornton and Andrew Rex. As usual, we first come to its statement. Okay, what is the binding energy of the electron in the ground state of part A deuterium, part B helium nucleus, helium He plus helium, and part C beryllium. Okay, so dear students, this problem has three parts. Actually, dear students, deuterium hydrogen has isotopes. First is protium, in which only one proton is present. Second is deuteron, in which one proton and one neutron. And third is tritium, in which one proton and two neutron. Okay, anyhow, this is not our basic concern. Now we are going to solve this problem. But before solving this problem, we will have to go through a few snapshots which will provide a foundation regarding solution of this problem, and will explain the philosophy behind this problem. Okay, first snapshot is about allowed energies. Allowed energies, En is equal to Z square. En is equal to minus Z square E naught over N square for n equal to 1, 2, 3 and so on, where E naught is equal to mk square e raised to the power 4 O divided by 2 h cut square. Here, dear students, k is constant 1 over 4 pi epsilon naught, and h cut is h Planck's constant h divided by 2 pi, and E is elementary charge of an electron, charge of a proton, etc. This E naught is alternatively given equal to 13.6 electron volt. Okay, dear students, this snapshot will provide a basic role in solving this problem. Okay, next, a remark is given that the nucleus of a deuterium atom called a deuteron contains one proton and one neutron. Okay, as I have already said that protium contains only one proton, while deuterium contains a neutron in addition to proton, while tritium contains two neutrons in addition to proton. Okay, next snapshot is in which a table has been shown. Okay, dear students, actually this table is very lengthy, consisting of several pages and a lot of columns, but I have chosen just a small part of that table in order to develop a sense of understanding. Okay, so this table starts from this, that Z, A atomic mass unit U, T half by 2 are abundance, decay mode, etc. Okay, dear students, I have chosen this table. Okay, number of, first comes hydrogen. It has Z equal to 1. Okay, 1, 1, 1, while for the time being we are not concerned with these. Okay, hydrogen has one proton, that is to say Z for hydrogen is 1, while for helium Z is 2. Okay, all are 2. Next, there is difference of number of neutrons, due to which its mass becomes increases. Okay, and third, there is beryllium. We see that beryllium has atomic number Z equal to 4. Okay, so 1, 2, 4, 1, 2, 4. Okay, these three are included in our problem, and and other. Dear students, in the next snapshot, an alternate approach has been applied and an other table has been shown to make this concept clear. Okay, this this table contains Z atomic number, that is then N neutron number, atomic mass, Z atomic number and N mass number. Dear students, here we see that 1 1 1, this is for hydrogen, then 2 2, this is for helium, and then 3 3, this is for lithium, and 4 4 4 is for beryllium. Okay, so from here this thing has once again become clear that in case of hydrogen we will take Z equal to 1, while in case of helium we will take Z equal to 2, and in case of beryllium we will take Z or atomic number 4. Okay, dear students, now we see whether there is any other snapshot or not. Okay, after this snapshot, next we are starting our solution in a regular manner. There is no other snapshot. Okay, now in regular solution of this problem we are using a snapshot which has been shown above. Okay, using En equal to minus Z square E naught over N square, where N is equal to 1 2 3 and so on, where E naught is equal to 13.6 electron volt. This implies that what we have done, then we have used the value of E naught in the above first line. Okay, this implies that En will become equal to minus Z square into 13.6 electron volt over N square. Okay, to this extent we have just reproduced the formula which was explained in snapshots. Okay, now dear students, ground state refers to N equal to 1. Okay, ground state refers to N equal to 1, so we will put 1 here. This implies that E1 becomes equal to minus Z square into 13.6 electron volt. Okay, because we are concerned with ground state, so we will take only E1, we will not take E2, E3, E4, E5. Okay, moreover we are going to generalize this expression in the next step. Okay, generally E equal to Z square into 13.6 electron volt. Okay, dear students, one generalization we have made, that in place of E1 we have used simply E, because we are not concerned with E2, E3, E4, E5, we are only concerned with E1, so it has been generalized as E. Moreover, we have taken positive sign. Okay, dear students, this point is still not very much clear in my mind, but it is clear that because answer is in plus, so we cannot take here sign negative, because energy is always positive. Moreover, there is a justification for this, that actually En is equal to 13.6 is a plus value. Moreover, z square is also a plus value because square can never be negative, and n is also square. It is also a positive quantity, and square can never be negative. Okay, so this is positive, this is positive, this is positive, everything is positive. So negative is not justified. Okay, anyhow, this point requires further clarification, which will be cleared in our next upcoming video lecture. Okay, anyhow, we have generalized this expression in this way that in place of E1 we have just used E, and in place of minus z square we have used z square. Okay, because answer does not accept minus sign. Moreover, 13.6 is also positive, z square is also z is also positive in square, and n is also square because it is positive. Square can never be negative, and hence every factor on right hand side is positive, and hence minus is not justified. Generally, E is equal to Z square into 13.6 electron volt. Okay. Now, dear students, we have already made it very clear that deuterium, which is basically an isotope of hydrogen, has atomic number Z equal to 1. Similarly, helium has atomic number Z equal to 2, while beryllium has atomic number Z equal to 4. Okay, 1, 2, 4. In above expression, these values will change only. That is, Z value of Z will change, remaining will be just constant. Okay, so for one time we will put Z equal to 1 for deuterium, then we will put Z equal to 2 for helium, and then we will put Z equal to 4 for beryllium, and we will get 3 different values of E. Okay, this implies that E is equal to E naught is equal to 13.6 electron volt. Because dear students, when we have put Z equal to 1, then we know that 1 square is 1, so E has become equal to E naught. So in case of deuterium, where atomic number is unity 1, E is exactly equal to E naught, and hence 13.6 electron volt. However, for helium, atomic number Z is not 1, rather it is 2. So E will become equal to E naught multiplied by 4, because the square of 2 is 4. So E will become equal to 4 E naught, and hence in place of E naught we will use 13.6 electron volt, and hence for helium E will become equal to 54.4 electron volt. Okay. Dear students, now we are coming towards beryllium. For beryllium, atomic number Z is equal to 4. So this implies that E will be equal to 16 E naught, because square of 4 is 16. So this means that 16 E naught means 16 into 13.6 electron volt, and hence for beryllium E becomes equal to 217.6 electron volt. And this is the end of our problem. This is the end of our video. Till next video, Allah Hafiz.